Good afternoon, ladies and gentlemen, and welcome to this webinar from the Association for Specialist Fire Protection on passive fire protection in modern construction. So we're just waiting for a few more delegates to join, and then we'll start again. So if you just hold fire for a moment. Okay, good afternoon again. For those of us who just recently joined us, welcome you to this ASFP webinar on passive fire protection in modern construction, given by myself, Technical and Regulatory Affairs Officer Nara, and our Technical Officer, Andrew Taylor. There will be a presentation followed by a Q&A. And for those of you who are not familiar with Zoom, and I'm sure most of you are now, you know at the bottom of the screen, there is a Q&A bubble that you can use to answer questions, and there's also a chat box, please. If you wish to ask questions and we can address these at the end, then please put them in the Q&A box rather than in the chat box. That's how it works. Our agenda today is going to concentrate on a number of issues, including why compartmentation is important, some rules and case studies. I'm going to mention a little bit about the ongoing review of approved document B. We're going to talk about how fire stopping is tested, because that's probably one of the major issues in modern construction and how difficult it is. My colleague Andrew is then going to talk about cavity barriers, and we'll also have some sources of guidance and some novel solutions. And as I said, we'll round up with the Q&A at the end. So the webinar is 1 hour for CPD, and that CPD is accredited through the IFE. So we've got to mention that we have a number of polls in this webinar to keep you awake and alert, and also to get some engagement. So we will now run poll question 1. So this asks, what is your interest in modern methods of construction? And you have a choice of a number of items that popped up on your screen, and you can choose one of them. And the results will come up, and as you can see, there's a few numbers of the client, most being other, and we've got a mixture of fire risk assessors, local authorities, approved inspectors, contractors, and designers. So that's quite interesting. So we move on from there. So methods. What is MMC? It's a very wide church, or a broad church, with lots and lots of different types of MMC. The most familiar one is timber frame at the bottom, because it's been around, one of the ones that's been around for the longest. But it also incorporates a number of other solutions, including precast concrete frame, panelized units, volumetric buildings, modular buildings. You're going to see a lot more modular buildings, or pre-manufactured units made in factories, shipped to site and joined together. and that has a number of issues that they have as well. And of course, SIPs, structurally insulated panel systems, are more of those. The benefits of MMC are fairly obvious, and, you know, especially if you're using a timber-based MMC, they are genuinely sustainable. You've heard in the news, we've got the COP26 climate change conference coming up. We've got net zero for 2050. You know, the old ways of making buildings and knocking down buildings are going to have to change. We're going to have to use more energy efficient buildings. And the other advantage is obviously they meet energy efficiency targets, they're quick to install, they're independent of weather, relatively speaking, and there should be less waste and so on. However, unfortunately, some MMC types and some constructions have had some fairly catastrophic fires recently. And we're seeing more of them, and the numbers are increasing as the numbers of buildings increase. Fires in MMC seem to spread faster and further with more disproportionate collapse and sometimes the total loss of the building. You've got two examples there, the Premier Inn at Cribbs Causeway and the Hamptons at Worcester Park. And both of those were very badly damaged. And although nobody was hurt, so from the point of view of the regulations, they work because everybody got out. But people start asking questions, is it actually acceptable for buildings to burn to the ground if that's okay? It's not very sustainable. More recently, those were in 2019, more recently, we had the Moorfield Hotel in Shetland, which is a SIPS construction. And that again was, you know, the fire service did their best, but really they didn't have a chance. And there was a complete loss of the building. So there's concern about MMC, and that leads us on to poll question 2, which is, are you concerned about the performance of fire in modern construction? And then you've got a number of choices. So I'll have a little while for you to answer that. And here are the answers. Significant concerns, yeah. Interesting, there are none for not at all. A few unsure, some minor, some major. So there's obviously some concern over it. You know, there's some disquiet, maybe the wrong word. Okay, so we'll move on for that now and move on to the next slide. So we move on to what is compartmentation and why is it important? Because that's obviously one of the most important things to consider. And it comes from the requirement in the building regulation. There's a series of functional statements, which is the small writing on the right-hand side of your screen. And we're talking about internal fire spread for the structure. And we're looking at number 3 there, where it's necessary to inhibit the spread of fire within the building, measures shall be taken to an extent, etc. Subdivide the building with fire-resisting construction. So construction, fire-resisting construction, compartmentation there is there to subdivide the building to manageable areas of risk to allow means of escape and to give the fire and rescue services time to rescue and for firefighting. So we have compartmentation, and the great thing, there is a great limitation, but a room full of compartments without any doors or windows or services wouldn't be much good. So we do have to knock holes in them. And when we knock holes in them, we have fire doors to make good that hole. But when we're knocking through cables and pipes and so on, we also need to ensure that the elements are sealed to reinstate their original fire performance. Fire resistance in terms of the performance parameters that are used is the integrity and insulation performance. We normally use load bearing capacity, integrity and insulation, but when we're looking at fire stopping, it's just integrity and insulation because most fire stops are not load bearing. In terms of European classification, we use this European class BSEN 13501 Part 2, and this is now referred to in the latest version of approved document B. You notice it says no BS tests. That's no bullshit tests. That's no British standard tests or classes. When the issue of fire stopping first came to the fore 20 or so years ago, as an industry, the committee decided we weren't going to develop a British standard, it would go straight into the European standard, and that's what we did. And then at the bottom, there's an example of two classes, E120, that's integrity for 120, and EI60, integrity and insulation for 60 minutes. It's not E160, which it does look like sometimes. Okay. So the rules you see come from, we got approved document B there on the right hand side, but obviously there are national equivalents in Scotland, Wales, Northern Ireland, and we also cover Ireland in the ASFP, etc. And those have provisions for fire resistance period depending on the building type, its occupancy, its height, and a number of other things. And there are various tables at the back with fire resistance periods that are required. So I'm now going to look very briefly at two case studies. Probably case studies is a wrong word, but examples of them. The first is the Cleveland Tower in Birmingham, which is made of traditional construction. And that was a fire in July 2017, which was about 2 weeks after the Grenfell fire. And it was on the 22nd floor of a 32-story block. And it was interesting in that fire, in that the fire was limited to the flat that was on fire. The building had a stay put policy, but in light of Grenfell, residents were allowed to leave. So 30 or 40 were allowed to leave rather than not being allowed to leave. But the West Midlands Fire Service Commander then said the building design, including its compartmentation of individual flat, performed as expected. And this happens in the vast majority of cases. In 7,500 fires in purpose-built blocks, purpose-built blocks of flats in 2019 to 2020, only 16 of them required evacuation of more than 5 people with a fire service. To bear that in mind. Contrast that with this one, which was the Beechmere Care Home in Crewe, timber frame construction, also burnt down in 2019, and it burnt down in 2019, and you can see the lower photograph shows you the remains. There's a kind of a loose H shape to the building, and there's one wing at the bottom right hand side of the photograph which has not been damaged. I'll come back to that in a minute. There were 150 elderly and disabled residents within the building. Fortunately, happened in the middle of the afternoon, so it was easy to evacuate them all. But although the building had the stay put policy, it was easy and simple and safe to evacuate them, so they did so. They did that. Cheshire Fire Service put in 16 fire engines at one point, over 150 firefighters, and they could not save that building. The fire was in there and it wasn't going to get put out, probably due to fires and continued voids. Cheshire Fire Service has also done a report, an inspection on the unburnt part of the building to see, is this a design issue or is it a quality construction issue? And we're still awaiting that report to be released. So that leaves some considerations for people to think about. We've had these number of high-profile fires in MMC construction. So DLUCH, as MHCLG is now called, the Department for Levelling Up Communities and Housing, and it has contributes to a committee called the Building Regulations Advisory Committee. And that has a subgroup on working on approved document B. And as many of you know, there is a review being undertaken of approved document B, not instantly. This is one that's going to take 2 or 3 years because there's research needed to do it. It's looking at all sorts of things like toxicity, etc. But in consideration of MMC, and again, I use that term loosely, ADB is based on traditional bricks and mortar construction, concrete, etc. And the idea is under B3, you notice I've highlighted a different piece of text up there now. The building should be designed and constructed so the event of a fire, stability will be maintained for a reasonable period. The idea behind that is that these buildings can withstand burnout, but with lots of MMC buildings, burnout can equal collapse, which is not what is desired and is not being maintained for a reasonable period. Therefore, the fire resistance periods in approved document B might not be enough, or you'll need to put in additional fire protection for MMC. There is some large-scale testing being undertaken by the industry, by the Structural Timber Association, in association with Effectis. And that's still ongoing. We're still waiting to see the results of that. But more large-scale testing is being considered by DLUC. I'm not sure what they're going to call it for short. So that's something that's interesting that's coming out. The other considerations are designers will need to establish if MMC is a common building situation. This is the term that's used in approved DB, and therefore whether or not ADB is applicable. If not, they should look to other codes such as BS 9911 or BS 9999. And ADB future revisions may contain statements to highlight that, or that might highlight that certain types of guidance is not applicable for certain building types. So, you know, the spotlight is well and truly on MMC and ADB. And the idea that it's just going to be published as it was before, I think is unlikely. I think that you will see changes that will highlight decisions that designers got to make. So fire stopping we tested. How do we test fire stopping? Moving back to fire stopping again, we've got service penetration seals and linear joint seals. And there's a number of test standards listed there in terms of numbers. I won't go through them all because once you've seen some of these numbers, that's it. If you're looking at the photograph, show fire stopping of pipes from the top photograph, and the bottom one is linear joint seals. Linear joint seals are linear or amazingly, and they seal that, for example, between two walls or between a wall and the floor. And often they're made of compressed rubber and this sort of thing. Fire stopping around the duct or damper, although it might be a similar material to the fire stopper used in a cable or pipe, it's normally a far more robust seal, and that's tested to a different fire test method. Most fire stopping is symmetrical, but obviously some cases it's not the case. And in some cases, fire stopping can only be installed from one side of a building. So many modular buildings, you see some in the factory in the photograph on the left, have been developed with asymmetrical details with a void that need to be fire stopped. And that will say sometimes you have to fire stop them from both sides, sometimes you don't, and both sides might need to be tested according to the risk. So we have published an advisory note 15. All our advisory notes are free to download from our website, which gives you more information on that. When you see the photographs, so the photographs I showed you before on the top one there, you see it's often it's actually tested in masonry or concrete, because that was where the industry developed it. But if you look at penetration sealing, typically penetrating concrete or masonry, can they be used to justify any MMC details where you may have combustible substrates? There's some manufacturers have done some testing, for example, for CLT, that's cross-laminated timber walls and floors, and the photograph at the bottom, or the diagram at the bottom, shows a PVC pipe fire resisting for 1 hour in 100mm timber walls. And you see the detail that's been put there. You may notice that there's a board that's placed above it. So compartmentation will be under increased stress if the supporting construction is combustible. Okay, that's an example, but we do see some fairly horrendous examples, one of which is going to come up now. I mean, these are old, not that old photographs, but you've got a fire-resisting pipe collar. Now, the collar is a device which is full of intumescent material, but it's made in a metal case. It goes around a plastic pipe. And the idea is when it gets hot, the intumescent expands and fills the gap left by the pipe as it melts. And they work very well. But most of them, if it's been tested in concrete, is it valid in a floor? And certainly not in the way that one's been mounted there. Okay, so what I'm now going to do is I think we go on to poll question 3. So this is a question which is going to run, which is what parts of passive fire safety design are you specifically interested in? And you can put all of them in, or you can put none of them in, or you can put one of them in. It's up to you. So we put those answers in. And our Georgina, our operator, will, when she's got enough votes, she'll give us the results and they'll pop up on the screen. And results are cavity barriers, penetration seeds, fire stopping is the main thing, yeah, but quite a bit on everything. Okay, that's good. At this point, we're now going to swap over to my colleague, Dr. Andrew Taylor, and he's going to take you on further. I will be back at the end to moderate the Q&A. So it's goodbye from me for the time being and hello from him.
Hello. Good afternoon, everybody. Hopefully you can see and hear me. He says. So here we go. We've obviously, Niall's talked a lot about issues with passive fire protection design, and I'm going to take that a little bit further. And some of you may have seen some of this before. You know, why is it important, and what happens, as an example, if passive fire protection design of fire stopping is not done properly? And of course, we take our classic favorite, the pink foam. It says it's got 4 hours to EN 1366 part 4 there, and that's a linear gap seal test, not a surface penetration test. And so if we take that and use it in an ill-advised manner in a surface penetration test, well, here we've got some where we've used the pink foam, we've put cables through a wall and we burned it, and the time to failure, a whole 9 minutes. So just because something claims a level of fire resistance performance, if we use it in an inappropriate way, it isn't going to work. And of course, taking a material and using it in an inappropriate way may not just be a function of the service that goes through it. It could be using it in an inappropriate design and with an inappropriate series of supporting constructions. We also have, there is, just as a warning from an ASFP standpoint, there is the infamous 40 mil plastic pipe dispensation that's contained within part B3 of ADB, table 9.1 that you see here. And basically any other material, if you have 40 millimeters, you can just get away with without using a proprietary seal. You can use just seal it for acoustic and whatever. And we've done that, and we've taken those and we have burned something using that guidance. And of course, we don't like it because what we found was that these things melt and burn and fail, polyethylene within 17 minutes. So we would have considered that approach A and using a proprietary seal is undoubtedly the best way. And there's an advisory note there, advisory note 2, which explains the full rationale behind that. And of course, the challenge that we regularly see, ill-conceived installations are a common problem. Now here we see a pipe band which should be embedded within mortar, and it's sat there. It's sat there with underneath a urethane foam held in place with a fire-resisting cable tie. I mean, the fixing instructions that are there on that right-hand picture clearly show that what it should be done, and we don't like it. And it's been done inappropriately, so you might as well not have bothered. Of course, the challenge is that design doesn't always help. How do you make sure that these things are properly fire protected? We've got the proper level of fire resistance. If you look at the picture in the right, it looks like it's a reasonable job, but there are a whole series of different things. There's there's a stud being cut here, which probably shouldn't have been, compromised the performance of the wall. The supporting construction, is there a sufficient distance between that support and the wall? And so there's a whole different, whole series of problems with and issues within this particular picture that could well bring you cause you problems with your fire stopping. You know, we need to make sure these things need to be planned properly before you start. One of my favorite pictures to show that, you know, design doesn't always help. Now here we have this picture, and I was looking at something on a site yesterday that was very, very similar to this. But we've got a cell beam there with a compartment wall below it. Now we've got so the compartment wall comes up to the cell beam, and ducts and dampers around the cell beam. So, you know, the damper's not in the plane of the wall, the damper's away from the plane of the wall. The ducts aren't protected in any way. There's no fire stopping around the ducts. The fire can go straight through the cell beams, you know, and the duct performance will not have been evaluated with the presence of a cell beam. There's a whole series of things that you would need to consider in doing that. And of course, and so there's a whole series of design issues and a whole series of different tests that you can come forward to that you would need to consider in putting something together for something that's as complicated with so many systems interfacing. Now, this one, maybe it looks a little bit simpler, maybe. Here we've got a series of pipes, cables, ducts, dampers, all in there. And whoever's done the spatial coordination on that's obviously done a fantastic job. One of the challenges is that whilst mixed penetrations of pipes and cables are okay, we're still awaiting the publication of the current standard for combined penetrations. It's imminent. And even so, I don't know whether you'd be able to get approval for a combined penetration with ducts and dampers and pipes and cables in the same opening. And I'm not entirely sure that those dampers are in the plane of the wall as well. So again, there's a whole host of things within that where better consideration of fire protection would have been earlier in the contract, would have helped the fire stopping contractor get to site and have something to do. One of the challenges, of course, for fire stopping is that there are all the different services that you come across pose a different challenge. And obviously Niall's shown a couple of pictures of some combustible pipes, some plastic pipes. They will melt and deform. So we need to fit a closing device to ensure integrity. And that will help with insulation. And it's the same with insulated pipes where we've got pipe insulation, because of course pipes insulation can burn and it can certainly shrink. And therefore you're going to need a closing device on pipe insulation where that, even if you've got a metal pipe in the center. Our metal pipe case, well, the metal pipe isn't going to burn, but of course the metal conducts heat, and it could be a way of conducting heat from the fire side to the non-fire side. So you need to consider how that could give you a problem with the insulation criteria that Niall was talking about earlier on. And it's this, and cables and cable bundles have a similar concern regarding conduction of heat and insulation, along the fact that with cables and bundles, you've also got the possibility of the sheathing to melt. And cable trays and ladders, again, with large metal things going through a wall, your conduction of heat and keeping your insulation is important. So if you're unsure about any of this, and I'm sure many of you know this, Red Book is a good source of information containing stuff on the regulatory requirements and types of fire stopping and how it's tested and assessed. And that's been the basis for a lot of this, but some of the last few slides also are covered in this particular document that we did joint with BISA, the FIS, the Dry Lining Trade Association, BISRIA, and the Gypsum Product Development Association. And so that's worth having a look at as well. Basically, the main thing that does is it's got some golden rules in it, and it specifically suggests that you cover your design of these things earlier and in greater depth in the design process. There may not be anything specific on modern methods of construction, but it's still an important thing to consider. And the key message of talk more, talk earlier is just as valid, if not more valid, within MMC. There are 9 golden rules in there to help deliver better fire stops. Again, please have a look at that, and although they're not specifically about MMC, they are just as valid, if not more valid. And there's a checklist in there for 37 questions, 7 about supporting construction, 3 about the opening, 24 about service. So that's an important, it's important to get lots of people involved when considering these things, because no one person is going to have all the answers to all 37 questions. And there's one final document to discuss. TGD 17 has a code of practice for installing and inspecting fire stopping. And there is a table in there that covers recommending inspection requirements. Okay, and of course, the amount of the inspection that's recommended during installation, at handover, and to undertake as you work and use and occupy the building. Okay, and then annually as part of your fire risk assessment under regulatory reform fire safety order. So there's lots of advice there. And of course, what we've been talking about, and what Niall's been talking about, is that for MMC buildings, it's as important, if not more important, to make sure that these things are being done correctly. Okay, where it's needed to help maintain the integrity of the building. I'm going to quickly talk a little bit of information about cavity barriers, why they're important, and what's the different types, the difference between open state and closed state cavity barriers, and a couple of things about how I think we do with MMC. Because there's an interesting question just come up. I may well be moving on to touch onto that. So, cavity barriers are important. Building requirements, building regs mention that bit of light text that Niall had on the earlier slide. Right at the bottom of it, it says buildings shall be constructed so the unseen spread of fire and smoke within concealed spaces is inhibited. And cavity barriers are designed to do that, and they should be E30 I15, except for where a cavity barrier actually is sat on a compartment line. And where it's sat on a compartment line, it has to have the same EI value as that compartment line. In effect, it's fire stopping. It's not a cavity barrier. And so when you look at this picture here, diagram from ADB, you see a number of instances like this one here, where a cavity barrier sat on there. It's not a cavity barrier. That should be a fire stop. That should be a fire stop. It's not a cavity barrier. That should be a fire stop. And you put cavity barriers in and around in other places, because where cavity barriers are to restrict the unseen spread of fire and smoke, but they're not in place of a compartment line where you have to stick to the fire stop performance. Now, cavity barrier performance per se can be affected by a number of things. Is it easy to get choose the right cavity barrier? Installation practice, NHBC ran some surveys, and there's the perception that it could well be somewhere as in almost half of cavity barriers are incorrectly installed. Installation practice, and one of the reasons for that is build tolerance, and you do need the build tolerance to be really tight, because otherwise cavity barrier doesn't fit and it just falls out. And of course, there is a level of movement in use and in fire. So you've got to consider those things when you're specifying cavity barriers. Now, how they're tested, and this is an interesting one, and one that's a bit of development. So we said we've already seen, Niall's shown that linear joints are tested to EN 3066 Part 4, and there's a linear joint product standard that's from that. However, cavity barriers at the moment, there's a subtly different test that's designed originally by IOTA for closed state cavity barriers for the mineral wool stop socks and the lights that you've just seen. And they're tested to an IOTA test, which is written in a document TR31. And there's a product standard ETAG 26 Part 5, although those are quite old and they've not been updated by IOTA for quite some time. Now, that text in IOTA TR31 forms the basis of a series of new tests, which will ultimately end up in a test standard called BSEN 1364 Part 6, as and when that is tested. Okay. And we hope that standard gets we're working towards the publication of that standard at the moment through the SEM process. In addition, we also there's a quite requirement for things called open state cavity barriers. And basically what we have here is in a desire to increase thermal efficiency of buildings, we get this retrofit insulation and a rain screen onto external walls. However, we have those external walls have a vertical cavity that runs the full height of the building. And in normal use, that cavity has to be open to allow water to and any stuff that gets in to be able to move down through that cavity and drain away. But obviously in a fire situation, we need that cavity to be closed. And we do that with a thing called an open state cavity barrier. That's usually achieved with the use of an intrumescent strip on a mineral wool backer. And the challenge is, how do we test those? And there is a test method. Actually, it was written by an ASFP group, and it's published initially by the ASFP as Technical Guidance Document 19. Was written by a cross-industry group of 12 members, including Warrington Fire, BRE and UL. And there's a suspended thermocouple, you can see the drawing there on the bottom right, where we test and we measure that suspended thermocouple, but we don't necessarily classify based on results of an insulation failure within the first 5 minutes. And that's based on practice in EN 1363 Part 1 and within the air transfer grill type standards. And so the purpose for that, but what I should say is the purpose of that standard initially was to validate cavity barrier performance for certification. We'd still recommend you've got to use the whole system to be tested before you go forwards, which you would do with BS 8414 testing. And again, this standard is being written hopefully into BSEN 1364 Part 6. Okay. One of the challenges is that cavity barriers and how cavity barriers and modular construction works. It's not really clearly covered by ADB. In fact, as Niall said, there's a series of questions. Do ADB recommendation apply? And we're looking at this going forwards. But I would say it really depends on the wall makeup and how the fire case has been put together. And as Niall's mentioned, our department of levelling up, I still can't get used to the idea of DLUTCH. Doesn't quite work as well as MHCLG. So DLUTCH are investigating the testing of cavity barriers, and there's some work to be done. But and there's a question I've just seen going through, and I think I'm hoping this might answer this. I'd ask this question. If cavity barriers and modular construction, where you bring 4 modules together, what's the fire case? So in this, what I've imagined here is that on the left-hand side, the fire resistance here is in the single skin. So what we're stopping within the single skin is the fire from getting from within the compartment of origin into that cavity, let alone into the next compartment. However, if we do it, traditional construction would consider that compartment and that void between as one construction element. So if all we're interested in is the fire going from this compartment through the cavity into this compartment, and so we say that the whole wall construction or the whole floor construction provides the appropriate fire resistance, then I will put it this way around. In this case, the single skin has the appropriate fire resistance. It may be appropriate to use a cavity barrier in that space, because what you're trying to do is keep the fire in this compartment. You're not worried about the fire getting into that line. You're less worried about the fire getting into that line, and you are just trying to prevent the unseen spread of fire and smoke, because you're trying to keep the fire out of there. However, if the fire is going from there to there, or is going from there to there in 60 minutes, then this junction here needs to be considered as a fire stop, and it would need to have the full fire resistance performance of the compartment line. So it's using a cavity barrier in that sort of a scenario, personally I would say, is an inadequate thing, because the cavity barrier will only give you E30I15, when in actual fact you may well need 60, 90 or 120 minutes E&I across that depending upon what you've got from there to there. And so that, to me, that's that needs the full-blown fire stop. And that's why it's very important, how's this been designed and put forward. A little bit of information on structural timber buildings. The STA has just produced a fire safety guidance document on cavity barriers and fire stopping. It contains information on regulatory requirements and types of cavity barrier used in timber frame, and there are some useful diagrams showing installation information. So I'll give them a mention and say that. But to be honest, there's still a load of areas where we need some guidance on this. We need stuff to come out for modern methods of construction on alignment and tolerances, compression, and movement. And of course, we've also got pre-installation protection from damage, weathering, and how much of this can be done post-install, and what checks and quality assurance are necessary on site. And so there's a whole host of things. I've just had a couple of technical inquiries come in as to how you would treat these sections here, these C sections, which are actually deemed structural because the things the modules sit on those. And so how do you deliver structural fire protection for those? And so there may well be a number of holes which in the guidance that's out there, which brings us to poll question 4. There you go. So would you like to see some more specific guidance on passive fire protection in modern construction? And this is a single choice. Yes, from us. Yes, from us in conjunction with the stakeholders, or no, there's probably enough information out there already. I'd be intrigued to know what you think. Here we go. So 80% of you, interestingly, nobody says there's not enough already. There's enough already, so there we go. 20% want it from us, and 80% want us to go out there and do something, but in conjunction with other people. So we shall consider that one, and we shall have a look at how we take that forwards. Right. So there's a last few slides here, and this is my standard webinar closing message, just as a reminder. As ASFP, you wouldn't expect an ASFP presentation without us sort of discussing the need for certification of third-party certification of products. And as we sit there, still waiting on the government's review of construction products and construction product testing, and the acts to come on from Building Safety Bill as a result of that. Our recommendation is that you still need third-party certification of product to give yourself the best chance of getting it right. Look, as a manufacturer, there are 3 ways that you can prove the performance of your product. You could just write a self-declaration, you could get a test report, or you can do the full-blown third-party certification. If it's self-declaration, I could say, yeah, I've designed it to, or it complies with a test standard. like how you design it to a test standard, how you comply with the test standard. You know, there's no guarantee that it's even been tested. And if it has, even if I've tested it, just because I've tested it, did it reach the required standard? Where was it tested? Who tested it? Was the test impartial? We don't know any of that information from a self-declaration, and therefore there's uncertainty and a consequent level of risk. If I had a test report, I could say my product was tested. Some people take a test report and say it's a certificate. It's not. But a test report is only a snapshot in performance on a given day. You know, was the test sample representative of what's actually produced? Has there been any changes to design, to incoming raw materials, and since it was tested? And so therefore, you've still got uncertainty. There's still a level of risk. But a third-party certificate, not only does it demonstrate the product's conformity, but a third-party certification organization should be auditing the company's production and the product and looking at the performance, and they should therefore be ensuring that the product is the same specification and design as was tested, which is the only way that is the route to confidence. Okay, so we always advise third-party certification of products as the best way to meet the requirements. And once you've done that, what you then want to do, because you're using third-party certificated products, is avoid somebody who comes along and creates some of these things, where products have been used inappropriately. I don't know whether you can get a third-party certification for fire resistance for blue plastic shoe covers. So, you know, there are poor installation examples out there. One of the issues that causes poor installation is design and build. And of course, there is no bar to entry for PFP installers. You know, all you need is a mastic gun, a bread knife, and a white van. Other colours of van are available. And so because of that, and because of the list of things that you see there, you know, one of the challenges is that fire protection can be poorly designed, poorly installed. It tends to be put into a contractor design portion, you know, and then once you've done it, there's no maintenance to follow up, and follow-on trades come along and smash holes in walls to run Cat5 cables. So from an ASFP standpoint, we'd always say that third-party certification of installers is important as well, and all our ASFP installer members have third-party certification. It's been a condition of membership for the last 20 years. And so we sort of say, you know, if you want a competent installer, competent contractor, use the member search on the ASFP website to find a third-party certified contractor. So we get to the summary question. You know, compartmentation and structural performance in MMC is a complex subject. There are some concerns, and ADB revision at some point is going to look at that, and there's going to be an ongoing review. But our standard mantra is, for the best chance of success, specify third-party certified products with the appropriate field of application, to make sure that if you are using it in MMC, has it been tested and as such, have it installed by third-party installers. And our members have lots of experience and hopefully can help you understand, get your correct outcome, which takes us nicely and neatly to the Q&A slide now.
The Q&A slide, indeed. Right, we have a number of questions, and hopefully they're all fairly straightforward to answer, or some of them are anyway. So the first one I'm going to mention is, obviously I keep the questions anonymous if people want to do it. It's a straightforward one. This is: proposed use of fire collar in a fire-rated plasterboard stud wall using test data from a masonry wall. Without official test data for this application, what other further information would you advise should be appropriate? For example, would the opinion of a fire engineer be suitable / enough? I think that's a nice straightforward form for you, Andy.
Well, it is. I mean, where do we start? Firstly and foremostly, there's no such thing as a fire-rated plasterboard. It's a the fire rating, the fire resisting performance comes from the whole scheme, which may well include EM520 type F boards. But it's but if we've got a fire resistant flexible construction, and you want to use a fire collar that's tested in concrete, I'd be really struggling without some form of evidence in a flexible wall to endorse that. You know, and I wouldn't have thought a fire engineer would want to give you such an endorsement. Advisory note 15 says you can go from flexible to concrete, but you can't go from concrete back to flexible.
Okay, thank you for that. The next question I have, it's a slightly more complicated one. In panelized curtain wall construction, do we need to provide cavity barriers within the hollow profiles of the wall panel? Sorry. So it's a two-part question. That's the first part of the question.
Panelized curtain wall.
My feeling was not, but I was looking at your diagram from approved document B, the one with cavity barriers versus fire stops, where sometimes in an external wall there is fire stopping in between the external wall, even though there's no direct connection. That's something we need to think about.
Yeah, that's one we need to think about. I mean, if it's sat on, you know, the cavity barriers, if it's sat on a compartment line, it would need fire stopping all the way through to the compartment. If it's beyond that, if you have a big run, you know, it's 10 meters between the floor, then you possibly do need them in there to keep that, shut that cavity down.
Yeah.
You know, that's the second requirement.
And the second part of the question, which I think is easier to answer, is there a maximum size of cavity under which cavity barriers would not be needed? Normally you have a 20-meter run. It's a maximum run in the roof space.
Yes.
The cavity barriers.
Yeah, it's the 20-meter run. Is the maximum size, isn't it? In there, and that's, of course, we're talking about ADB in the UK here.
Yes, yeah, that's right. Yeah.
Well, ADB in England and Wales.
ADB in England now.
Yeah. But ostensibly the same provisions exist.
Some more questions are popping in now, so I'm going to go a bit faster. How important is it to access transparent digital data for ASFP members? For instance, do you agree that we need to better understand and provide evidence of material we're specifying, purchasing and installing on our construction sites?
Yes, is the answer. It is very important. It's for buildings in scope of regulatory reform, fire safety order. It's there. There are requirements under Regulation 38 to keep accurate records. It's something that's has not been done well historically. It can lead to all sorts of problems as in maintenance, where, you know, or change of use, where we don't know what's on a building, and somebody comes along and needs to do some maintenance and can't start, doesn't know where to start, and it's costing people a fortune, because you end up virtually having to rip what could be good stuff out because you don't know what it is and how it was installed. So I think it's very important.
Yeah, I'd also add that transparent digital data is at the moment, there's too many different formats, and this is still a developing science. How important is it? At the moment, not terribly, but it will be terribly important. And we do need to better understand and provide evidence of materials. There's all sorts of consultations undertaken, for example, the lexicon consultation on building information modelling. Also for buildings covered by the Building Safety Bill, i.e. those above 18 meters in height, there will need to be a golden thread of information from design through manufacture, design through purchasing, installation and maintenance, and that golden thread will be digital. So at some point we've got to embrace this digital revolution. Now, the next question is a nice simple one. For modular construction, there would be or could be steel, timber and concrete. Are the guidelines the same, or which one is the toughest to design a fire stop system? So you've got a choice of steel, timber or concrete.
Right. The answer is the guidelines are the same, because you're trying to deliver, what you're trying to deliver is the same. So the guidelines are the same and the test standards are the same. But which ones, you don't want fire to be able to go through it. You don't want heat. You may not want heat to be able to go through it. Integrity and insulation. And so that guideline is the same, independent of what your supporting construction is. And all three of those pose different risks. Concrete's possibly the easiest to design a fire stop system around, because it has both insulation properties and it's non-combustible. Steel could conduct heat and therefore it gives you issues with insulation. Of course, timber is going to char, but so probably concrete's the easiest. The other two have their own challenges. But you would need to consider all three separately.
Okay. Right. The next question, it's partly a comment, but I'll say it's I have seen a 50mm plastic pipe with 10mm thick wall tested to 2 hours protection using sealant. Doesn't specify what's type. No collar is used, and this gives the false impression to customers that a sealant will work fine for a plastic pipe. I think it depends on the type of plastic pipe. But,
it depends, and on the type of sealant, of course.
Yeah.
Because there are some sealants out there that are full of graphite and designed to work in that sort of an application.
So that's your alternative A there in that respect.
It's still alternative A. It's still proprietary system accordingly.
Right. Next one is there training suitable for site managers working for main contractors who are dealing with specialist contractors installing PFP products, bearing in mind the contractors installing PFP are third-party accredited, but nevertheless still don't always get it right?
That's a really good question. Can we talk about that on our wrap up?
Okay, all right. I'll try and remember to go back that one. Next one is unlike concrete, there is no redundancy in MMC. We have a huge legacy issue out there. How do we prevent the drive for new homes that are going to be modular or timber from adding to the problem? What checks and balances need to be developed? That's a big question. That's a good question as well.
It's a very good question, and yes, I think that question gets to the nub of the thing. And if ASFP are going to work with other stakeholders, and we saw there was a question, a couple up there where I saw it said, who are you going to work with? The answer is we need to obviously there are some checks and balances that need developing to make sure that the things are properly tested and robustly tested with a level of to work as appropriate for how it's all being designed. And we're going to have to get both the designers and the manufacturers of these things together, along with our own members, and discuss how you install them and interface them.
Yeah.
And I'd also say that the two people who posed that question and the previous question, they will be getting phone calls from us to see if they would like to get involved. Yeah,
that's true. I mean, we do have some interface with the Structural Timber Association.
Yeah.
In that I sit on some of their steering group panels, but not in respect of straightforward timber frame. It's more in respect of cross-laminate timber, where there are other issues there's issues of concern, and that's in terms of what happens when these structures are involved in fire, in large fires longer term, and do they delaminate and so on. And that's why there's a need for some large-scale testing, because I would even say fire resistance testing is possibly not adequate to determine the structural stability of some of these three-dimensional structures you know, sticking a wooden wall in a furnace and getting the result is not the same as putting a fire in a three-dimensional wooden structure where the connections are maybe questionable or not adequate. Okay, our last question on this list, we're finding that it's the funding and insurance providers are currently driving the construction industry to non-combustible buildings, regardless of height and building regs requirements. With this in mind, does the ASFP have any feedback from the financial industry on the use of MMC? Certainly, I've not heard any feedback from the financial industry. Perhaps they mean mortgage providers.
What they mean, mortgage providers or insurers.
Yeah.
Yes, I mean, there is some discussion within the insurers committee about this and about what they're looking at, but I've not heard anything from mortgage providers. That's an interesting thought. And there is some interesting discussions within the come on, what's the now the Association of British Insurers and their group.
ABI.
Yeah.
I mean, insurers are certainly have some concerns, but
they do.
There's two issues. There's life safety and property protection.
Mm-hmm.
And so far for life safety, kind of doing okay. There's no really perceived increase, but you know, a lot of people are saying things like the Beechmere care home fire, the near miss, a very near miss, and if it happened at 3 o'clock in the morning, but they may not have been able to evacuate everybody straightforwardly. That might have been quite a different result.
Might have been very yes, there might have been a very different outcome. Okay.
Yeah.
Do you want me to rattle through the last couple of slides?
Yeah, I think that's all. That's fine. Yeah. Okay.
I think we've done most of the questions.
Yeah, I think we all, yeah.
I hope.
Yeah.
In which case, just as a couple of last couple of wrap-up slides, if you want to see us in person, ASFP is back on the road again. We were at the fire safety event at the NEC, and ASFP will be at London Build on the 17th and 18th of November. And there's a little linkette there for you. We're there on the 17th, aren't we? Niall and I. So if you want to come and see us, that's where you can come. Well, that's where you can meet us in the flesh, rather than a two-dimensional thing broadcasting live from Lancashire or Sussex.
East Sussex.
Okay, and then somebody asked a question about training and training for site managers, site supervisors, and whatever. We run ASFP do run a training course. We have I'm sure as many of you know, we work in conjunction with the Institution of Fire Engineers. We have a level 2 and a level 3 examination on passive fire protection. They have a level 2 and level 3 passive fire protection exam, which is registered with Ofqual. So it's an equivalent to a GCSE or an A level. And we do a 5-day training course. And there you see there's the level 3 one there. There were 2 dates. There were 2 courses being run, one in East Midlands and one in Watford. They're full, but there is now an e-learning availability, and there will be more dates for those coming out soon. Have a look at asfptraining.org.uk if you are interested in that. And as you log off now, there will be hopefully a post-webinar questions to give us some feedback on what you thought of this, etc., etc. I think the next one is meant to be Wednesday, the 10th of November on fire doors. Hopefully more detail on what we're doing next will be announced shortly. But keep an eye on the ASFP website. And that's us. I'd say thanks to Niall for putting up with my random button pressing. At times I got it was a bit too fast, and at times I was a bit too slow.
Yeah, it was a bit. Yeah. One of the questions, which unfortunately I pressed the wrong button, was we know there's an issue, and as a sector we should not allow another major disaster to occur on our watch. We need to make this very, very visible to DLUCH. I'll just simply say they're very aware of it, and that's why I put those slides about the consideration of ADB, where it might even say you know, if you're using this type of construction, you can't use ADB.
We shall see.
Which should ruffle some feathers, because
Right.
what will happen otherwise is they'll hide behind ADB. Anybody, oh, use the statutory guidance, therefore I'm covered. Well, maybe you're not. And the statutory guidance needs to make clear of when a common building situation is used. Okay, sorry, I'm ranting now.
Oh, it's all right. Thank you very much.
Okay.
Let's say thanks to everyone for attending. If you want your CPD certificate, info@asfp.org.uk, please. We'll see you all soon. Thank you.
All right, thank you and goodbye.